In today's video, we are going to be adding / subtracting rational expressions. So to do this, we are going to factor everything that can be factored. So the top can be factored, and it's going to be factored into a minus 4, plus this is already factored for us. It's already in just one form, and then we're going to divide. The bottom is the same, can be factored. So we're going to have a plus 3, a minus 3, a plus 3, a subtract 3. Okay, so now the denominator is the same. Just like when you're adding and subtracting regular fractions, you want the denominator to be the same on both sides. In this question, our denominator is the same, so it's just going to be easy to, we're just going to go ahead to add the numerator. And to do that, we're just going to draw brackets and collect like terms. Okay, so for this one, the denominator is going to stay the same, a plus 3 and a minus 3. Right, we're just going to pick one. And then for the top, we're going to draw brackets and add similar things. This should be a. Okay, and then we're going to have a. So that's still multiply a minus 4. But now we're adding. Let's erase this. But now we're adding a plus 4. So our final answer is going to look something like a plus a, 2a, negative 4 plus negative plus 4 would be 0, over a plus 3, a minus 3. And this would be our final answer. If we ended up with, let's say, a minus 3 on the top, we can divide the a minus 3. We can cancel it out with the 1 in the bottom. But this would be our final answer for this question. Okay, so let's do a question where we don't have the same base. How are we going to do that? Okay, so here we have this. We're going to, again, factor all that can be factored. The top can be factored into a plus 5. A minus 5, subtract x plus 4. We're going to divide by a plus 3, a minus 3, over. Okay, this should be a's. So a. A minus 3. Okay. So how would we go ahead to solve this? So now we factored. We look at the base, and the base is not the same. So we can't just go ahead to be like, oh my god, it's the same. We're just going to go ahead and take this away. No. So in order to make the base the same, we have to look at what each of them are missing. So for this one right here, we have a plus 3, but here we don't have a plus 3. Here we have a minus 3, and here we do have a minus 3. So what is missing is a plus 3. And in order to get it on this side, if you remember back from adding and subtracting fractions, all you have to do is to multiply the top and the bottom of this side by a plus 3. So we're going to multiply this side by a plus 3, which is automatically going to put a plus 3 here. And then we're going to multiply the top by a plus 3 as well, which is automatically just going to put a plus 3 there. That's why it's important to factor it, so that way you can see what is identical and what's not. Now we can go ahead to subtract. In order to subtract, so now to subtract the top, I'm going to do something. I'm going to take back what I've done. In order to make this easy to subtract, what I'm going to do is I'm going to change the top back to a full expression, so not factored form. So I'm going to change it from the factored form to a non-factored form. And how to do that is I'm just going to FOIL it, and where the top is going to be a square minus 25. Subtract. The bottom is going to stay the same, so I'm just going to keep that. A plus 3 and a minus 3. But now this is going to be subtract a squared plus 12a plus 12. Like so. So 7a. So now we can collect like terms and just add those. So here we have a squared, but now we're subtracting. So it's going to be a squared subtract 2a, which is going to cancel out. That is going to cancel out. So we're going to have our equal sign. That's going to cancel out. So we're not going to do anything. So we're going to be left with 7a. Because it's nothing. And we're going to have negative 25 plus 12 would give us negative 13 over a plus 3, a minus 3. Now, if you could go back to factor the top, go back to factor. Because now that we've subtracted, we could have a like term on the bottom, but that question is non-factorable except I use the quadratic formula, which would take ages. So that would be our final answer. So that's it for this video from solving or adding and subtracting rational expressions. I hope you guys learned something from it. I will see you guys in the next video. Bye.